Good morning, students, and Happy New Year. Last time you have studied the scintillation counter method for detection and measurement of radioactivity, and today you are going to study the G.M. counter, that is Geiger counter. And the principle of the Geiger counter, it is the alpha, beta and gamma radiations, they ionizes the gas. Here, all the nuclear radiations such as alpha, beta and gamma radiation will ionize while passing through a gaseous medium. When these rays passes through gaseous medium, they ionize the gas, and this ionization property, it is utilized in the GM counter. In GM counter, the central wire acts as anode and the and acts as a cathode. Here the cylinder, it acts as a cathode. Then a Geiger counter consists of Geiger tube, the sensing element which detects the radiation and processing electronics results in display. Geiger tube is filled with an inert gas such as helium, neon or argon, and 90% the tube is filled with any inert gas, specifically the argon gas at low pressure, to which a high voltage is applied. Then the tube briefly conducts electrical charge when particle or photon of incident radiation makes the gas conductive by ionization. Here, this is the schematic representation. This C, it is a copper cylinder having 2 cm width and 10 cm in a length, and in this tungsten wire it is suspended, and here it is a mica window, and in front of this the radioactive source it is kept. The radiations from the radioactive source, they penetrate this mica window and enters into this gas cylinder. Here the argon gas, 90% argon gas and 10% ethyl alcohol is filled. Then here it is a anode. Then here it is a voltage applied source, and here it is a amplification unit. This is the schematic representation of Geiger counter. Then construction of Geiger counter. Here the cylinder, it is sealed a glass tube of radius 2 to 3 cm enclosing a coaxial metal cylinder serving as a cathode. Thin metal wire, it is stretched along the axis of cylinder and serves as a anode. The free end of anode is covered with a glass bead to avoid corona discharge building up at a sharp point. Thin window made up of mica or other material provides for counting less penetrating radiation like alpha or beta. Inert gas like argon is filled in a glass tube with vapors of some volatile compound like ethyl alcohol. It acts as a quencher of a gas. In the ratio 10:1 is added to it. In some counters, neon gas is mixed with trace of halogen. For example, bromine as a quenching vapor is used. The gases must be free from electronegative impurities such as CO2, O2, which will tend to form negative ions and initiate secondary advance, secondary avalanche. Then the characteristics of G.M. counter. The rate of counting is recorded as a function of voltage. A graph between voltage and rate of counting is called characteristic curve of a counter. When the voltage is low, counter operates in a ionization chamber region where there is no gas amplification. The voltage pulse will be small and no counts will be recorded unless the voltage exceeds the threshold voltage. The average increase over threshold counting rate increases as a gas amplification sets in and output pulse size increases. This is a region of proportional counter where more and more low energetic particles are counted until the point C is reached. From this point onwards, the counting rate becomes constant. The flat region CD is called plateau of counter, and suppose this is a counts per minute and here it is the applied voltage, then the counts increases here and remains steady, and this region it is called as Geiger plateau or plateau of counter. Then as already I have told you, G.M. counter consists of a fine wire mounted along the axis of a cylinder cathode made up of glass or metal with a metallized inner coating filled with a suitable gas mixture. The gas mixture usually consists of argon 90% at 10 cm of Hg and ethyl alcohol 10% at 1 cm of Hg. These are the pressures. The diameter of cylinder cathode varies from 1 cm to 5 cm. Its length varies from 2 to 100 cm depending on the purpose for which it is used. The circuit to which G.M. counter tube is connected to detect the particles in shown below. Here again this is a schematic representation. This is a metal cylinder. This one is a tungsten wire. It acts as an anode. Then here it is a mica window, and here the ionization radiations they passes through the mica window, enters into the metal cylinder, and the ionization of gas takes place. Then here suppose this is a count rate on y-axis and here it is on x-axis. Suppose we have voltage, then the nature of the graph we have like this. Here this region is called as proportional region. This region where the counts per minute it is constant. This region it is called as plateau region, and again the CPM rate increases. This region is called as continuous discharge region. And when the potential of the cylinder it lies in between the ionization chamber, at that time we can have the Geiger plateau, or this is also called as a plateau region. Then the same diagram here, and this is the Geiger-Müller G.M. counter explanation. Thank you. Later on we will see the range of alpha particle.